another one that I would like you to understand is the noisy channel model. As I mentioned earlier, right. So, we can look at a source and there is a target, right. So, when the source is transmitting certain data through the noisy channel and then the decoder receives the corrupted version of the source. Okay, the idea of the decoder is to really estimate what really created that data that it received. So, ideally it should find the exact source of this, right. So, in real situations, since it is corrupted by noise, it is not possible for you to exactly get the source. So, we get some estimated data, so or some guessed data, and then the guessed data would be close to certain confidence level that we prescribe. So, if it is close to that confidence level that we have prescribed, then we pick up that as the probable source and move on. If you map the noisy channel for the machine translation, we have the source language model that generates the source language, and then the noisy channel can be considered to be a translator. Okay, so, given an English sentence, translate it into French. Okay, and assuming that the noisy channel receives the language, receives the sentence in English, and the translated model outputs the French sentence. And then what we need to really estimate is what actually source had in mind, or the source language model had in mind, and that is what we want to find out. So, decoder actually tries to estimate the source which created the French language. Okay, so, this is the idea here. In this case again there could be multiple, decoder might be giving multiple versions of E dash. We use the argmax to really find out what exactly or what could be the probable sentence that I want to use as the translated version. So, the language model here, okay, generates an English sentence E. Okay. So, as I mentioned, that generates an English sentence. The translation model transmits E as a French sentence as its output. Okay. The decoder finds the English sentence E dash, which is most likely to have given rise to F, right. So, we want to find out which one really would have created this. That means, we are going back into this. Okay. So, if you are able to really estimate the accurately what really created F, then we have really gotten the right or the best translated version of the source. Okay. So, I think this is, if you are a bilingual, you understand this extremely well. Now, as a bilingual, when you start to speak English and your mother tongue is not English, you form your sentences using certain words in your native language in your mind, and then output the English sentence. Okay. What the decoder really wants is what you really had in your mind, that output the English sentence. So, that means, I want to really understand what kind of words and the language model that you have used internally to generate the translated version of English, and then I just want to estimate the source that it created the English language. So, this I think is very common for people who learn to speak English. Initially, they frame their sentences in their native in their mother tongue and then speak out the English sentence. Okay. So, this model is exactly similar. We want to estimate what really created this F. So, we want to estimate the source using the output that it was generated, and then estimate to a certain level of probability, and then see how close we can match with the language model that we had used. Because the language model gives us what is the probability of the sentence that is created here, right. So, if the sentence is not in the right order, then the probability is going to be very low, right. So, we have already seen that there is a probability model that we can generate for a language using bigrams and trigrams. We will have some recap after this, and then use that or apply that onto the decoded language and then see how close it is. Okay, so we would be able to estimate this and then find out whether this E that is decoded is good enough to be called as a good translated sentence using the model. Okay, so there is another one that we want to look at here. This is the Bayes rule. It's a very simple rule that breaks down the problem into two smaller problems. So, again we are going to be assuming a French sentence and we like to translate that into an English sentence, right. Okay, from the probability perspective, we want to find the English sentence that has maximal probability given the French sentence. So, using this rule we can write the equation of this type, where the probability of estimating this sentence in English given the French sentence is given by this formula. It is a product of the conditional probability and the product the language model, and in the denominator we have a language model for French. Since it is the numerator is independent of this, we can actually ignore this and we can write this as okay. We have to now estimate two things. Okay, so we have two problems in hand. One is to estimate the parameters of this, and then the next one is to estimate the model for this, right. So, we call this one as the translation model, okay, and this one is our English language model. So, if you are able to estimate these two distributions, so we should be able to find out the English translation given the French sentence. Okay, so, this is something that we have obtained using the Bayes rule. Okay. If you have to get the parameters for the translation model, we have to estimate the parameters of this using all the training samples that we have in the parallel corpora. Okay. I will just rush this through. It is possible to estimate the word, second word in a bigram given the first word using the count, right. So, in the same fashion in the trigram given two context word should be able to estimate the third one and so on. Again it is based on the counts. Okay. So, this we know very well, and then we also know that the data is sparse and there is always newer ways of constructing sentences. So, we should be able to allow the new sentences in the model, and we do not want the model to fail when new sentences are given, and if it does not find the distribution for the new sentence, it should not say that I have not found anything, right. So, there should be some mechanism to really smooth that. The reason why we want to have that is, if the conditional probability is 0 in one of those cases, the entire sentence would fail. So, we just want to avoid that 0 probability. So, we will try to smoothen that using some mechanism here. So, even a newer sentence in this case will have a very small value. We also know that it is possible to estimate the parameters given the corpus. Okay. And then using the corpus, we know that it is possible to estimate the next word depending on the context that is provided by the previous words, right. Or using the word to vec model, we should be able to get these words filled in either using the skipgram or CBOW. Okay. In some cases, instead of the multiplication of all the probabilities, we use the log, so that the entire multiplication becomes additions, right, to avoid some underflow problems. All right. So, how do we evaluate? I think there is always some gold standard available, so that the translated version is how close it is to the gold standard. Okay. So, we probably would use the same Bayes rule to evaluate this model as well. And then we also spoke about the perplexity earlier. So, the lower the perplexity, the higher the confidence the model has with respect to the sentence. Okay. So, again this also we know well.